Thursday is History Club and golf, and Friday is History Club. SBA.
Alright guys, we are continuing with this graphing piece today, so really nothing new, not adding anything to it. We're going to do some more practice. When you guys feel confident, then I will give you some more to do individually. So it'll be very similar to yesterday. We are going to do some together first though.
Okay. Can we do like 2 or 3?
Yeah. I'm not going to do 2 or 3 is good.
Bless you.
I'm about to say, because I'm confident.
On this one, what is the first step?
Factor.
Factor. How would you factor the top?
Out of 3x.
Okay, so if I take out a 3x, that leaves me with x minus 1. Alright, on the bottom,
Easy. X plus 4x minus 3.
alright. Then we did the x-intercept. So x-intercept is when y equals 0. The shortcut I gave you yesterday, what part of the fraction do you really... Yes. X-intercept is really just when the top equals 0. And we get 2 of them. 0 and 1. It's the benefit of having everything factored first. It makes it easier to identify those.
There's going to be the y-intercept.
So y-intercept, if you plug in 0 for all of your x's, you can do it the original or the factored form, whatever is easiest. So we get 0 divided by negative 12, which is 0.
Wouldn't it be negative 1?
Well, 0 times negative 1. Vertical asymptotes, those are x equals, what would that be?
X equals 3, x equals 9.
Then we have to decide if it's horizontal or oblique. So we look at the degree. What's the degree of the top?
2.
The bottom.
2.
If it's the same degree,
Divide the coefficients.
so 3x squared divided by x squared.
Grapher.
Alright. On your graph, you have to have everything plotted that we just found. So we hit the x-axis at 0 and at 1. Y-axis at 0. Vertical asymptotes at 3 and negative 4. Those are dashed lines. Then we had a horizontal at 3. When you graph, you need to include parentheses around both the top and the bottom.
Graph the factor form of it?
Yes, but make sure you put an extra set of parentheses around the top.
Three-person graph.
Alright, so you should get a graph that looks like this. When we plot this, does it just turn into a flat line between the 0 and the 1?
Yeah.
No, because then you would hit the x-axis at everything between them. We only hit the x-axis at those 2 points. So it's kind of hard to tell without zooming in on our graph, but what it's doing is...
I was confident. I'm good. Worth a shot, man.
So we should get something like this.
You miss 100% of the shots you don't take.
Exactly.
You miss 100% of the shots you do take. Nah, I don't.
Alright.
Right now, I'm making it.
We need to do...
One more. Let's start with, you're not even recording.
open slide, so you would have x squared minus 5x plus 4. What's that factor into?
X minus 4, X minus 1.
And then we have to divide the 2
X
back.
minus 2, X. Oh my gosh, there's a whole.
Sorry, correction.
Okay, over x squared minus 4, how does that factor?
X plus 2. Oh, there is a.
They cancel.
Okay, I talked about this yesterday, but we didn't see it happen. These cancel. So my final factored form is 2x minus 1 over x plus 2. This is what we will use when we're finding intercepts, asymptotes, all of that. But when something cancels, we can't just ignore it. This means there is a hole in our graph. At, and you have to give me the ordered pair. So the x value of that ordered pair comes from the thing that cancels. What makes x minus 2 equal 0? Okay, to get the y, you plug 2 into what's left. So you would get 4 minus 1, so 3 over. So at positive 2, positive 3 fourths, we have a hole on our graph. X-intercept is really just what makes the top 0. So the top was 2x minus 1. If that equals 0, what do we get? Y-intercept, if you plug in 0 for all of your x's, again, I'm just using this reduced one. So we get negative 1/2. Vertical asymptote. X equals what makes the bottom 0, so that's negative 2. Horizontal or oblique. It can be off the original or a factored one. You will get the same answer. The degree is the same on top and bottom in both of those, so you just divide leading coefficients, so 2 over 1 is 2. Alright, so if I go to plot this. Horizontal at positive 2. And look at the y-axis at negative 1/2. X-axis at positive 1/2. How do I show the whole?
Open circle.
So positive 2, positive 3/4. You have an open circle. Alright, so then I am going to graph this on my calculator. That's 2x squared minus 5x plus 2 over x squared minus. Notice the calculator doesn't show the whole here because your calculator automatically reduces it before it graphs, but you have to have it on yours. Draw your curves approaching your asymptotes. Make sure you go through all the points that we've plotted. And don't accidentally fill in your open circle as you're drawing it. So it looks something like this.
Do you do the first equation or the
Either one should give you the same thing.
But you have to double press to see the final. Right.
Yeah, if you like did this fine. Or the
Alright,
back.
we're good. We're good.
Alright. Is that one okay?
Yeah, we're good. We're good.
We need some more?
No, 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 no.
Do we need to practice an oblique?
No, 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 no.
I have a handout.